Hello, welcome to the part 4 of the course about creating a subway tunnel. In this part we will cover 3 topics. We'll go back a bit and refine the pattern at the very beginning of our setup quite a bit. We'll discuss the organization of the project and my approach to it. We will start to familiarize ourselves with the LOP context from a practical point of view and create a convenient hierarchy of objects in the LOP context. We will use the already learned approaches, only this time to create procedural lighting. We have a lot of stuff to cover, so let's get started. Before we start, I wanted to clarify one pretty important thing. When we initially create our cuts, so at the start of our setup, right after we basically generated the sweep, we have used repeat block to perform these cuts. But actually what we can do if we happy with just uniform cuts, we can just use carve node as usual, set first V and second V to 0 and 1 respectively. It could be first U and second U, depends on your particular case. And you can just increase V divisions. And that way you have multiple primitives, which will be equal to this result. But we actually have created kind of framework for us to add some variation to tailor it to our needs. And for example, I wanted to have slight randomness in my vertical cuts. So what I can do, I will remind you that this input here in our particular setup is just unchanged input geometry on each iteration. It just keeps adding itself here. But here, what we have is the result of the previous iteration. So it's kind of goes from here to here. And in this particular branch, we can add attribute wrangle and, for example, set it to detail. I will use spare input on this attribute wrangle, add spare input, and we will reference the repeat begin. The same result we will have if we connect it to one of inputs of attribute wrangle, but I want to stay consistent in terms of tools I'm using in this particular area. So I will use spare input, but generally there is no difference in this particular case. So let's start calculating unit, which is kind of step. And let's call our float variable unit, and it would be equal 1, but be careful here. We need to explicitly state that 1 is float. So 1.0. In other case, if we type like this, we will have a result either 0 or 1 without any decimal places. And that way we explicitly stated that we need float result. After that, we will need detail -1, and we will reference num iterations -1 as usual, because we start our iterations from 0. So this is our unit. Then we can create variable called, for example, rand, and it would be equal rand as a function from detail -1, but this time it would be the current iteration number, so it would be iteration. And because I'm in wrangle now and I'm using vex and not hscript, we don't have to set component number on detail function. And as usual, as a second argument, we can use sit here. Let's create sit. Nice. Then we will remap this random value. So random value would be equal fit01 from itself to two additional channels. It would be channel min and channel max. So minimum and maximum value. And then we will generate attribute called previous, and it would be equal plus equals itself plus unit plus random. And that way we reference the value from previous iteration and we have set it to new iteration. Because we didn't initialize this and because this is a float attribute by default, it would be resolved first time as a 0. So it would be equal 0 on the first iteration. We could have set it here, so attribute create and attribute previous, but in our case it doesn't make much more sense. And now I can create null to easily reference this, and I will call it previous. An attribute wrangle I will rename as a current. In carve node we will get rid of these expressions here and we will simplify it a lot. So I will add additional spare input on the carved node, add spare input, and first one would be previous and second one would be current. So basically in this null, the value of previous attribute on detail would be equal its state here. And in the current, we already kind of generate the next iteration. So hopefully it makes sense. And first v would be equal detail minus 1 and attribute that we have generated just a previous. And because we in HScript, we have to set component number. And then second v would be equal the same expression, but the input would be minus 2, which means this spare input 1. And by default, we will have exactly the same result. Let's just add color. Let's randomize it for each primitive just to see random. So as you can see, right now it's equal, but when we add our parameters, and I will probably change the parameters range from minus 0.1 to 0.1. I mean min and max parameters, because it would be really sensitive. But as you can see right now, I'm gradually increase or decrease this. You can see each segment generated slightly different, but be careful if we will subtract too much, we will cut our thing. So it's better to have slight changes because it's quite a large scale here. And because of the way carved node is working, as you can see, when we have something equals 0 in terms of its length, it won't generate any primitives. So as you can see, as I increase the maximum amount, which means I have value beyond 1, it won't generate any primitives. So be careful about this also. So I want just a slight touch of randomness. It would be extremely small. But what we can do also, just to have more control, we can measure this thing here. We already actually have the backbone, but let's assume we don't, and we want to stay in this particular loop without generating any additional external data. We can just extract the line. So it would be carve again, and we just set first u to 0.5, and we will extract this line. We will measure it. What I want to do is to convert my relative values to somewhat absolute values. So I will set it to perimeter. Now we have attribute called perimeter. I will set it to second input because here we have only one primitive at the moment. We can get the calculated length of this primitive. So let's add additional float variable. Let's call it L just for sake of time saving. And we will get value from prim. Right now it would be 1 as an input. Attribute that we need is perimeter, and we need this from 0 primitive. And now we can divide our random by the calculated L length. And so after we have divided this relative value to absolute value, we actually have this in more or less meters. That way, when we decrease the length of the spline, we will still have the same amount of randomness for each iteration. And we have more precision. So let's check the colors. We can use exploded view to test if we have any nasty intersections, and we don't, which is really good. But this is optional thing, definitely. But you can get fair amount of additional control and fine-tune to your models and to your patterns using this particular way. But again, just to remind you, you can do the same if you find with uniform segments. You can do the same just using one carved node. It probably would be even faster. I've gone ahead and made some organizational work, and let me quickly run you through this. This is my usual approach. It's not the only one, but to me it works fine. So basically my approach is to try to separate any logical steps, like any distinct logical step. For example, with wires, we have step of generating the main curves from which we will generate the cuts. Then we have created our copies, and then I just meshed these wires basically. At this latest stage, I prepare my geometry for output. So I clean attributes if it's necessary and so on. And additionally, I extensively use the object merge node that helped me to separate these blocks logical blocks, I would say. And if I go to the view and I will set dependency links to show for all nodes, you can see that there is actual connections between the nodes. And as you can imagine, if I had this in my network, it would be pretty cumbersome to manage and it would be pretty easy to make a mistake. For example, if you connected the nodes that you didn't want to connect by accident, this helps to prevent it. And also, like a quick note on color coding, it's pretty simple. I tried to again separate my steps in terms of like initial generation, first step of generation, which usually stands for first level of details, means the largest details, then second step, which corresponds to the middle-sized details, and so on. And basically I go from top to bottom, and top usually my initial geometry means red, and the out usually purple. And it helps me to easily identify on which step I need to add some changes or do slight adjustments, or simply which step I need to reference. And also I prefer not to name my network boxes. From the distance it's pretty hard to see, and of course colors help, but I prefer to have like really distinct names and really easy to spot, so I can spot it from distance. And this is just a comment block, and I simply disable the background, hide background here, and I set text size for large or extra large, and it definitely helps. And also I wanted to mention that now we have some cables torn, and I have a separate session on this, which is pretty much ready for upload. And I will upload this particular part about creating this hanging and cutted cables a little bit later. So stay tuned for that. Let's work on setting up the LOP network in order to get access to Karma render. Here I collected all my geometry, everything that I've generated, and basically I need to reference this one in LOP network. We can go to the stage context, but I prefer to create LOP network in obj level. It's just easier for me to think about. I will create LOP network, and basically what I need to do is just sub import, and let's choose the geometry. We can filter it easily. Geo collect out. Accept. So now we have our geometry, and let's go to the Solaris desktop here. And a quick note on the Solaris context. I'm going to oversimplify the point, but from a practical standpoint, it's easier for me to think of the LOP context or the Solaris context as a procedural constructor for the hierarchy in the USD file. And I think of the USD file itself as a universal project file that can be modified in many applications like Unreal, Blender, Maya, and so on, while remaining editable in every aspect. And what is also important, it can refer to other similar universal projects that will be modified independently of the main one. Also, traditionally in Houdini we have fully procedural contexts like SOPs and DOPs, and semi-procedural object network, where we can link objects like cameras or lights or containers to each other, but we can't create them procedurally. So we have to use Python or something like this to create it on the fly, but it will be like a semi-procedural and it will be kind of hacky. But USD blurs this distinction and allows us to work with scene objects like lights and cameras in the same procedural manner, which we will kind of implement in its simple form during this lesson. So for now, my hierarchy is practically the mess, but we're about to fix this and we're about to handle different parts differently. So let me just store quick mark, pressing Ctrl 2 in this case to easily jump to this particular network. And let's go inside of our subway network, and I will set the quick mark here. So right now we can jump between two states. One thing to note, Solaris context is completely ignores wherever lights we have in our OBJ level, because here we will create lights tailored for this particular context. I will construct this hierarchy on the fly Right now it's just like some default stuff here, and I will decide by myself what hierarchy I actually need. Let's start with bottom part, and we can go to the obj merge, press this arrow button, and then press F. And that way we will be transported to the node that was referenced in this particular obj merge node. So let's create attribute wrangle here. And I have two ways of setting this path attribute. So let's create string attribute path, and let's start with just calling the channel string channel that we will call path. Usually we use something like geo. In this case, it's tunnel, and then we will have rails, and then here we will have slippers. Or we can do something a little bit more convenient, at least to me. Let's just create a new attribute wrangle. Let's set it to primitives, and let's go to the edit parameter interface, add folder. We will set this folder to multiparm block list or scrolling, wherever you prefer. And the name of this one would be paths. Label would be the same. First instance would be 0. It is important just to keep an eye on this first value. Usually I prefer 0. And let's create a string, and string would be path underscore and path spacebar and hashtag here. Let's call it apply. So now we have automatically added hashtag here, and the hashtag would be resolved to index of current parameter in multiparm block. As you can see, it's path 0, path 1, path 2, and so on and so forth. So we can clear it, and let's create a couple of variables here. And the first variable would be string, and it would be called out, and it would be empty for now. Then I will create a parameter called, let's say, separator, and it would be equal just a forward slash. Then I need to get this amount here. So let's create integer variable called iters, and it would be equal channel integer. We will reference this paths channel that we created before. So it's technically not a folder, but integer channel. And let's create a quick simple loop for integer I equal 0, I less than iters, and I plus plus. And here out would be equal itself from previous iteration. So out plus equals separator plus channel string. And here we will reference path. Let's reconstruct the name of this channel plus integer to string I to a, I from I. So like each parameter would be the new index. And let's set this path attribute to this out variable. Right now it's empty, but we can start to fill this hierarchy. So it's geo, tunnel, rails, slippers. And basically it's exactly the same result, but what we can do right now, we can just, let's color this one path set, and let's go to the next one. So this would be not the slippers, but rails. Now this one would be the bottom, and let's say floor. Let's copy this one, and let's name others. So for example, wires, and let's extract the wires geo, and we don't need the last one right now. Or we can call it cables, just like this. And this one would be wires holders. And keep in mind, we will handle it a bit differently later, but for now, just to have this. Actually, let's disconnect this for now. We don't need this. It's the source of this nasty thing that we had before. So let me just quickly show you. Because of using so right now go to the wires, and you can see we have a bunch of instances, which is actually pretty okay in our case. We have prototype of this holder. Maybe that's all right, but we can, for example, make additional level of instancing, so wires, holders. So just to, this a bit better. So as you can see, I can easily control my hierarchy in the LOP network using the path attribute inside of subs. So we can go further and just finish with these parts. So it's actually the geotunnel walls, this upper pattern. This one would be bottom walls with shade pattern, for example. You can come up with different names for this one. And actually we pretty much done with the naming here, because I no longer see this unnamed mesh 0 primitive. And now we can go inside of LOP Network and we can select each of these primitives or groups of primitives easily, and we can perform some operations on this. So yeah, this pretty neat. Let's go further. So let's extract some points for our future lights. We can go to the point where we have our vertical slices, which is awesome, because right now we have access to different stages and we can sample them. So I will copy this node, vertical slices, and I will create obj merge in some nice spot. Obj merge, I will paste this. I will set it to export the relative path. And then I will use carve node. I will go to the 0,5 in U axis and I will set it to extract. That way we have like each primitive that will match our vertical cuts, which is exactly what we need, because I need to place my lights kinda in the middle. So to do so, we just create additional carve. Of course, we'll set first hue and second hue to 0 and 1, and we will extract this, and then I will use fuse to get rid of any duplicated points, and let's call it ceiling light. I will create a network box, and I will use nice orange color for this, just to see that this one is about lighting. Let's create a null, ceiling light, and probably let's delete each second of these points. So I will create delete node, delete by range, set entity to points, and that's probably okay. Let's go to the LOP network. I just pressed 2 to go there. Let's create instancer. In this instancer, if we go inside, we have just a subnetwork as usual. And here we can use object merge and we can search ceiling light, press accept. Let's modify it a bit by moving it slightly lower, something like this. Let's go outside. Let's create light node. Let's append it to instancer. As you can see right now, nothing happened, like literally nothing, which is not what we want. I will disable this one. And to make it work, to make lights work with the instancer, we should set it to reference. And that way, as you can see, we have our multiple lights created automatically. So I was too extreme with the moving it down. Something like this. So I can create just some geometry here. I can use it as a geometry light at some point. So as you can see now, we have lights placed exactly where we want it to be placed. And we can disable the showing of lights in the viewport by pressing this button here, so we no longer see the gizmo of this. And now we can create merge node and let's say duplicate this light. Let's actually correct this particular light to something different, slightly different, so kinda orange, and let's increase its intensity, set exposure. We already can fire up the karma render. It will take not that many time to load the scene because we're still in the fairly lightweight geometry. So second light could be a little bit more on the red side, and we can create additional light which will have no lighting at all. So just like a blind spot of it. And simply by just appending this to the merge node, we can control the probability of each light, which is kind of brute force approach. We can control it using the attribute. In instancer, in the options, we can go to the prototype index, and as you can see, we can set some index attribute that will help us select the needed lights. We can extract some additional info about lights. So it could be lights placed exactly here, for example, and we can use the same points to instance the geometry. So let me just quickly show you. Let's go to the LOP network, and again we will create instancer. And one crucial thing here, we should keep an eye on our hierarchy here. And as you can see, for now we have instancer primitive. Each item in this hierarchy on each level would be called primitive in USD. Just a little sneak peek on terminology. And primitive path would be the light. So right now we have this instancer name because it references the name of node itself. So if I press middle mouse button, you can see that now this name resolved. And we can rename the node itself, and let's call it ceiling lights. Now we have primitive called ceiling lights. And let's create additional instancer. So we will use the same stage as before. And let's go inside this instancer, again, object merge, select the ceiling light null, and let's move it slightly downwards. And as a placeholder, we can use, for example, sphere, because we can make it a lot smaller. Put this one, let's decrease its size. So something like this. And of course, here you should place like your real light, but spheres also works fine. And because we used like a parametric approach, spheres / lights in the place that we actually need. We can again parameterize the placing of the lights just to avoid manual adjustment of positions, but generally it's working kinda okay. And one super nice thing about this approach is the fact that now we just changed the random seed and we have a different lighting for each case, which is really awesome. We can extract some additional curves. For example, we want to place some lights here on this side. So let's go back to the subnetwork, and this time let's use the walls null, which means without any cuts. We will object reference it as before. Let's place it near our ceiling light. Let's go here. So, and here I can just extract some curves. I can use the usual expression which will connect U and V. So paste relative references, 1 minus first U. And let's extract these curves. And let's resample it. And let's generate some normals here. It would be on points. We can call it, I don't know. Let's pick the normals for now. Let's check the amount of points, because it's too many right now. Something like this should work. And at this point, we just slightly pick this just to avoid intersection. Something like this. Can I pick this after? Yeah, it's better because we keep the same amount of points, which is nice. And again, network box. Floor light. Null would be floor light also. Nice. Go inside LOP Network and create additional instancer. We'll call this floor lights to automatically create the needed primitive. Go inside, object merge. Let's call floor light, accept. Let's pin this view. Let's go inside of our subnetwork and let's adjust the peak value to have no intersections here. We can use the same lights as we created before. We can use new ones. So for example, we can easily copy all this merge just to have it separate. And here, for example, I want to create additional white light, a little bit of saturation. And for example, here I can change the type of light. It doesn't matter actually in this case. So yeah, this is the main part with setting up the scene. So as you can see right now, we have pretty understandable hierarchy. It's not the best. So what's the instancer 2? Let's go to the ceiling lights geo. So not bad. We can of course use different geometry for this one. This is our starting point, and in the next lesson we will continue with setting up the textures and all the necessary attributes for the textures in Karma Render. So thank you so much for the watching. See you.